Hey everyone, and welcome to Who Will Win the Chem Nobel, predicting the 2016 Nobel laureates in chemistry, a special broadcast brought to you by Chemical and Engineering News, along with ACS webinars. I'm Matt Davenport, a reporter with C&EN, and I will be one of the hosts for today's webinar. I will also be joined by Lauren Wolf, an assisting managing editor at C&EN, and you, our audience. Please feel free to ask questions or chime into the discussion during the webinar. You can do this by typing your message into the questions panel in the webinar. You can also join the discussion on Twitter by including hashtag ChemNobel in your tweet. The slides and a recording of today's webinar will be available later this week on the C&EN website at cen.acs.org. And that's about it. So now I'm pleased to turn this party over to Lauren to get today's Chem Nobel presentation started.
Great. Thanks, Matt. Welcome, everyone. A wise person once said that for chemists, the announcement of the Nobel Prize in chemistry is like the Super Bowl, March Madness, and Oscar night all rolled into one. Oh, the anticipation. So everyone wants to know who's going to get the call from Sweden. Some people want to know so badly that they get up at 5:30 in the morning to find out. I'm not talking about anyone specific, but C&EN is particularly fond of Nobel season. This is the 4th year running that we've held this prediction event, and I never get tired of it. It's pretty fitting that one of our esteemed panelists this time around was actually our original host of the very first one of these that we did, Carmen Drahl. She is a former colleague of mine here, so welcome, Carmen. She hosted, as I said, the very first one of these. She's now a freelance writer for outlets such as Forbes.com and Princeton Alumni Weekly, so we're excited to have her here today. Our next panelist is also no stranger to these prediction events. Stu Cantrill, chief editor of Nature Chemistry, joined us for our second hangout, and he's back for more, so I have to assume that he either had fun or he didn't win, and he is determined to get the win this year. All right, finally, please welcome Alex Spokoyny, currently an assistant professor of chemistry at UCLA. And fun fact, C&EN named Alex one of our talented 12 rising stars in chemistry this year, so we think he's pretty awesome. Fun fact, as part of Alex's profile, he said that he likes to argue, so stay tuned. I can't promise presidential debate fireworks, but it'll be good. All right, so we're going to talk briefly about how the nomination and selection process for the Nobel Prize in Chemistry works. Then we're going to share our predictions, which is the main event, and we're going to talk about winners from the past. But don't think all you viewers are just sitting there listening. We're going to ask you to cast some virtual votes throughout this, so don't fall asleep. Stay with us. And finally, we're going to open up the floor to questions to you, the audience at home. And as Matt said, you can use the questions panel or you can use the ChemNobel hashtag. So we'll be monitoring the feed. All right, so let's get started. Just to make sure we're all on the same page about how the Nobel Prizes work, I thought I would give a very brief background. So Alfred Nobel signed his last will in 1895, and much to his family's disappointment, you can see that he left a majority of his money to setting up these prizes. And some of the language you can see here, but his main requirements for the prizes were that they be given to people who during the preceding year had made the biggest advance to help mankind. As we all know, that sort of preceding year decree hasn't held completely true. The Nobel Committee has since taken a broader interpretation of that statement. So typically they award prizes to people whose work has been recognized as important in the preceding year or impactful. So that's sort of like saying that Professor X discovers unobtainium in the year 1988, but in 1989 people didn't really appreciate the value of unobtainium, but by 2009 that's when they realized that it had this unlimited energy source, and they gave him the prize then. So for the chemistry prize, Nobel specified that it would be awarded by the Swedish Academy of Sciences. And so today, a committee of members of this academy are the ones who do the job. So there's typically about 5 members, but for chemistry, it sometimes has expanded a bit. What I'm showing you here is this year's committee. And starting last September, these folks would have started sending invitations for nominations. And who are the scientists that they send these invitations to? It's sort of a, I don't want to say elite group, but it's a very particular group. They can be past Nobel winners, they can be famous chemists across the globe that are specifically selected, they can be members of the Royal Swedish Academy of Sciences, among others. But the point is that the invitations are special and the nominations are kept secret, or they're supposed to be. Which brings me to this little database that C&EN has put together this year. 2 years ago, Nobel Media released a digital archive that revealed who was nominated each year for the Chemistry Prize between 1901 and 1963. It's sort of a treasure trove of insider information. The idea is that they'll tell you who is nominated, but they only release the data that's 50 years or older. So I suppose that's to protect anyone who's still in the running now. But in any case, we decided to source this data from the Nobel Prize site. We cleaned it up and we made it searchable. And we have this little visualization which is showing you that there, between 1901 and 1950, there were 1,987 nominations submitted for chemistry. And what was I going to say? Okay, so there were 1,987 nominations submitted, and oh right, so if you go to the site, we have some little fun facts. We take you through a data visualization that we've pulled out of that data. You can see, here's one interesting fact, perhaps depressing, but there were only 7 women nominated between 1901 and 1950, and 2 of them won. And we can also tell you some other fun facts, and you can explore the data. So one other fun fact, the person who received the most nominations during that period of 1901 to 1950 was Walter Nernst for his thermodynamics work. So you can see the data here, you can play with it, but we're going to ask our first poll question around nominations, and I'm going to turn it over to Matt to do that.
Thanks, Lauren. So what we'd like to know from you, our audience, is who would you nominate for a Chem Nobel if you could? Please log your choices now. We'll shut down this poll in 5, 4, 3, 2, 1. I tried to go slowly to give people time to read. I know that was dramatic. Oh, CRISPR-Cas9 actually came up with the win at 39%. Gray, Holm, and Lifford came in second with 21%. Does that surprise you guys? I guess I should ask. Let's start with Alex. Is that surprising?
No, not actually. It's not. But I'm happy that well, I'm not revealing anything what I'm nominating. But I think this is about what I would expect.
All right, well, let's go to why we asked you these particular people. We didn't just make them up out of thin air. These, in fact, we asked our panelists each who they would nominate, and these are some of the answers that they gave. So I'm going to let each of them tell you about their particular nomination and why they made it. So let's start with Alex.
So I decided to nominate Harry Gray, and I think so I teach inorganic chemistry to undergraduates every year here at UCLA, and we spend discussing a lot of fundamentals like ligand field theory and some bioinorganic chemistry and electron transfer, and one has to realize that sort of the contributions that Harry has provided to the community, both on the fundamental side of things, from his early work with in Copenhagen with Bellhausen, sort of refining the ligand field theory, which then goes all the way into the modern bioinorganic chemistry and the electron transfer chemistry. I think these are the knowledge and the tools that everybody in the greater community, not just inorganic chemists, but a lot of other folks use. And I think if you also look at the trend, right, the inorganic chemistry haven't received a Nobel in quite a bit of time, and so I think it's it might be a good time for somebody like Harry Gray to receive a Nobel Prize finally. So
So Alex, do you view that as like a, if you were to get it, it would be more like a lifetime achievement award, or do you think they'd pick one area of the things that he's done to award?
Right. So the contributions that obviously Harry has provided to the community, there's so many, right? And it's hard to pick. I don't even have a favorite one. I think they're all important. Based on what the Nobel Committee has been doing in the past, right? These haven't been really lifetime achievements, right? They have been picking for specific areas, and I think if one would choose maybe bioinorganic as sort of a subset, then yeah, that might be what Gray will receive the Nobel Prize for. But there might be other things, right? So the fundamental electron transfer, or even the sort of something like ligand field theory, right? These are past overdue, and that's something that everybody in the catalysis community, you name it, all of this theory is invoked everywhere, and it hasn't really received the Nobel recognition yet.
Okay. All right. Well, let's go to a panelist. So, Carmen, why don't you tell us about your nomination?
Sure.
Who actually won?
Yay. Well, so, right, I nominated Jennifer Doudna-Emanuel. I would nominate Emmanuel Charpentier and Feng Zhang for CRISPR-Cas9, but it's a little bit of a complicated and controversial choice, right? CRISPR-Cas9 is this precision gene editing method that is letting people pinpoint where in the genome they want to make tweaks, and the ease of this has been really it's set off kind of a next generation of bioethics questions, questions of application, not to mention the patent controversy that's ongoing. But I think what would be cool to see if this prize were to win is that it is a little bit more in tune with the Alfred Nobel will and the intent of picking something that is recent, but for which the impact is large and pretty obvious. You have also the component of basic science, because CRISPR-Cas9 comes from ancient bacteria and how it was an immune response, and it just goes to show you how little we still know about bacteria and how cool they really are. But that said, it is a little bit early, and we talked about how it can take time to hammer out all the kinks to see what limitations are. Ash Jagalkar at the Curious Wave Function had blogged his picks earlier, and he talked a little bit about CRISPR-Cas9, and I think his words were, I don't think there's a reasonable soul who thinks CRISPR doesn't deserve a prize, but there have been some studies in the last year that still point to there's some kinks that need to be worked out in terms of specificity, efficacy, different systems. So, while there's a lot of excitement about this area, and Thomson Reuters, the citation information agency that picks Nobel winners, has given CRISPR a nod in the last 2 years, we may not see the Nobel Committee want to touch this one just yet.
Yeah, I wondered about that, because I think some people have said, just because they haven't worked out all the patent issues, that maybe the Nobel Committee will stay away from it until they've worked that out. I don't know if you had any thoughts about that.
Oh, I mean, Nature wrote a news article about, just in general about controversy in the Nobels, and I believe it was in that article that maybe awarding it to the right 3 will go some way to, settling the stormy seas. But I don't know. Maybe they wouldn't want, the Nobel Committee wouldn't want their award to become part of a patent litigation suit.
Yeah, hard to know. All right, let's keep this moving. Let's ask our next panelist to describe his nomination. Go ahead, Stu. It looks like you had some trouble choosing.
Yeah, so I cheated. I cheated on many different levels as well. So So I went with two different sets of nominees, and for the first one I couldn't actually decide. But basically it's for click chemistry, the development and the application of these reactions where you take very simple building blocks, click them together in quick, high-yielding reactions where there are minimal byproducts or inoffensive byproducts, is I think what the original paper says. And it's just this concept. And it seems there is some controversy. We're not talking CRISPR levels of controversy here, but if you read some of the articles that have been written about click, it's, oh, this isn't a concept, this is nothing new, this is just simple and easy reactions. But the fact is since they were first proposed, or since the concept was first proposed in 2001 by Sharpless and Finn, I think, you see them everywhere. They're all over the place, but more importantly, they're used in a whole range of different things. It's not just, these reactions are not just used in a synthetic sense for making molecules. They're used very much for bioconjugation and doing reactions in live cells, but also for materials chemistry as well. So it's one of those things where I'm speaking to a few people around the office. Some people had already assumed that Sharpless's prize was for click chemistry, which obviously his first prize wasn't. But the question is could Sharpless win a second Nobel? Could he be one of, well, he probably would be one of the people if they gave the prize for click chemistry, which is where my Pauling t-shirt comes in that you can't all see because Pauling's obviously won 2 Nobels. But the more I started digging into this, then you get this complication of who should actually get the prize. And I would abdicate that responsibility completely to the committee. So I have 6 names on there. And you can look at people like Bertozzi, who has very much gone into the development of click chemistry. But Huisken, who did a lot of research many years ago about just the fundamentals of 1,3-dipolar cycloadditions. So that's the first one, and hopefully everyone can see for the pick number 2, this is my sort of fantasy, incredibly biased. If I did get a nomination, I'd just nominate this because I'm as biased as hell, but I love molecular machines. I think it's brilliant what you can make little molecules do. You can make switches, you can do all these wonderful things. Of course, I did my PhD with Fraser, so I'm sort of biased in suggesting I would nominate him for a Nobel. But I think, so the other names that you'd have to include there, you have to include Thuringia. So Stoddart comes along with that. And I think Dave Lee, in terms of molecular machines, done some really neat things. So again, in Fantasyland where I get to nominate, I'd be putting in a nomination for molecular machines.
Stu, do you feel like, just because we talked at the beginning about, you know, when they award prizes, like it has to be an area that has sort of made an impact or something for, you know, humankind. Do you feel like molecular machines is there yet, or, I mean, that, I don't know.
No, I really don't think it is, but I think it's possible to have Nobels for fundamental scientific discoveries that maybe haven't changed the world and maybe will never change the world. Have fullerenes changed the world?
Well, yeah, I think one example also would be that graphene won before, you know, we really are still waiting to see what graphene's going to do as well, right?
Yeah, so again, I think I said on the slide, the real-world applications, there may never actually be any significant real-world applications, but it's just so cool.
Yeah. All right, well, I'm going to keep this moving along just to get to the main event, the predictions. I did make a nomination, so that's what Joanne Stubby was on here. You know, I also really wanted to put another woman on the list. I will admit that was, you know, one of the reasons I put her on here, but one is just because she's awesome and she deserves it. You know, she has done a lot of work to sort of uncover how enzymes do what they do. She figured out some radical mechanisms. Specifically, I know her pet enzyme is the ribonucleotide reductase. It's the thing that basically takes a ribonucleotide and makes a deoxyribonucleotide, which is the sort of building block of DNA, so kind of important. And, you know, that's also led to some possible anti-cancer drugs and things like that. And I will also plug that one of her lab members on her website is her dog, Dr. McEnzyme Stubby. So yeah, she's awesome for that reason alone.
Who goes by nickname Zyme, so.
Zyme, yes,
Yeah.
yes, I saw that. But I also, I think like Stu, I couldn't help myself. I put another person down here, and I think it was a little bit because I wanted to see what people thought about Bob Langer. I mean, he's won just about every prize there is. I would be hard-pressed to figure out one that he hasn't won other than the Nobel. I wonder when he sleeps. He's had 31 startups in 30 years. And I would guess that if he were to get it, it would be for fundamental mechanisms in drug delivery. I'm not sure. This is one of those where it could be a sort of a lifetime achievement prize, but we've talked about that and that maybe that's not possible. Is that a reason? What do you guys think, Stu? Maybe do you think that this will?
Well, I mean, some prizes are, they say they don't give they don't, Lifetime Achievement Awards aren't really what the Nobel is about, but it's very easy to see some of them in that light. I mean, I would put George Whitesides in a similar sort of category here to Langer, in that he's done a lot of amazing things across a lot of different areas. How you actually sort of roll that all up into one Nobel Prize, I'm not sure, but is that fair? So I don't know. It would be hard to pick out one particular thing, but I mean, Langer and Whitesides are certainly Nobel worthy. It's a question of what do you write in the citation?
Yeah, that's a good question, Carmen.
Yeah, I mean, maybe you have to think about Alfred Nobel's will like the U.S. Constitution, in that it was written at a time where you couldn't possibly envision what would happen to science in the intervening time. I mean, now, when Nobel wrote his will, I mean, he certainly had commercial applications for dynamite, but the wide-ranging achievements of somebody like a Langer, maybe, it wasn't quite the same. Although I personally would nominate him for a Nobel Prize for taming my frizz on a rainy day in DC like today, because that alone, tops.
Yeah. All right. I actually think I just saw a question fly by where someone was saying that both Alex and I didn't really give multiple nominations in sort of our categories, and I won't speak for Alex, but I will just say, I took this literally like, okay, the Nobel Committee has asked me who I'm nominating. I picked specific people, but definitely, within these categories. I mean, maybe not Langer. I'm not sure who else I would put in a category with him, since we're having trouble even defining what he would be winning for besides, maybe drug delivery mechanisms. But certainly for Joanne Stubbe, there would be other people in that category for enzyme mechanism discoveries. And Alex, I don't know, who else would you put in that category with Harry Gray?
Well, I think Harry Gray is unique, and so I just didn't feel comfortable clumping him in with anybody else. that was my rationale. Yeah. So, but there's absolutely many other individuals in working in the field that are certainly deserving of the prize. But I think just
Okay. All right, well, let's keep moving on, because as I said, we want to get to questions from, more questions from the audience, but we also want to get to the main event, which is next. So we've now talked about who we would nominate. That's very different than who we think is actually going to win this year. Who are the front runners? Who are the people who are on the top of everyone's odds lists? And so let's get started with that. We're going to go through each of our picks, and then we'll open up to you, the audience, to vote. So let's start with Stu.
So this is kind of the easy option. This is one that has been talked about for a little while. So I'm basically going for lithium-ion batteries. I can hear Neil Withers cheering a couple of miles down the road, I think. I think this was Neil's pick, maybe last year or the year before. Lithium-ion batteries are ubiquitous. They are absolutely everywhere. There's one in the laptop that I'm talking to you from now. There's one in my iPhone where Twitter notifications keep popping up. They have changed the world. They have made devices mobile, and it's one of those prizes where I think there would be no arguments. No one is going to go, oh, lithium-ion batteries. Oh, that's not chemistry. It's one of those ones where I think its time has come, and its time has probably been ripe for the last, I don't know, 5, 10 years. There's no doubt about what lithium-ion batteries can and have done. It seems the problem comes in with, if you look at the types of prizes that the Nobel Prizes give, in physics you do get sort of these technology prizes. So there was the blue LED prize not so long ago, and there was CCDs and fiber optics and giant magnetoresistance. So sort of prizes for very sort of practical technology advancements, grounded in fundamental science, of course. But for lithium-ion batteries and chemistry, you can't really point to a chemistry prize that is sort of for an everyday technological advance. The chemistry prize seems to be much more fundamental. But that needs to change, and I think this would be a brilliant way to do it. And again, with this one, I mean, these are the 3 people that I've picked. Stanley Whittingham, John Goodenough, and Akira Ishino are the 3 you often see. So Stanley Whittingham and John Goodenough sort of started the whole lithium-ion batteries thing. John B. Goodenough came up with a practical one, but then it was developed into commercial product by Yoshino and others. But there are also people who worked on graphite anodes as well that you could throw into the mix. But I think these would be the 3 I would pick, and it's about time.
I just saw someone in the question window make a joke about Samsung, which makes me laugh, because actually I was rereading a profile of Goodenough earlier today, and one of the things it mentioned was when he developed this cathode for the battery, one of the things that was important about that was that it didn't blow up. Basically, it didn't start on fire, and it just made me laugh. It would be coincidental if that happened this year.
So batteries are in the news, so
yeah,
wouldn't that be cool?
It would be cool. All right, let's go to the next pick. Carmen, go ahead.
Sure. So this is a pick for polymers. So I'm picking Krzysztof Matiaszewski, or Matiaszewski from Carnegie Mellon, Izio Rizzardo at CIRO in Australia, and also in Australia, David Solomon at the University of Melbourne. So this is really a prize that, to me, ticks a lot of good boxes. The way Stu said about lithium-ion batteries, this prize is definitely chemistry. This is polymer building methods. This is about making molecules. So what this is, about half the polymers out there in the world are made by free radical polymerization. And, you know, trained as an organic chemist, I know that these radical reactions have a reputation of being rapid, uncontrollable, willy-nilly. And what these folks did, this is independent discoveries. This is a class of reactions that they developed that get classed under something called reversible deactivation radical polymerization. So what they do, they understood the chemical structure of radicals, they predicted how they would behave. These are methods that essentially let you rein in that out-of-control polymer growth, let you control polymer properties by controlling their structure and their molecular weight. And you know, Matiaszewski is known for something called atom transfer radical polymerization, but Solomon developed nitroxide-mediated polymerization, which is the earliest of this kind of class, and Rizzardo with RAFT, or reversible addition, fragmentation, chain transfer. So the second tick box is that, like lithium-ion batteries, there are applications of this chemistry that everyday people would recognize. It's in cosmetics, it's in inkjet printing, it's in automotive coatings. This chemistry is being used at places like Mitsubishi, at IBM, at L'Oreal. And the third tick box is that this trio has won a lot of prizes that are what are considered a bellwether for the Nobel Prize. In 2011, Matiaszewski won the Wolf Prize in chemistry, and in that same year, Rizzardo and Solomon shared the Prime Minister's Prize in Science in Australia. And Rizzardo and Matiaszewski are both citation laureates over with Thomson Reuters. So, I mean, there are other versions of this kind of polymerization chemistry. I think if the Nobel Committee decided they wanted to honor this kind of chemistry specifically, it would not be a one-person prize, but it wouldn't necessarily be the 3 that I've chosen.
Okay. All right. I'm going to keep this moving just for time here. So let's go to Alex's pick. Alex, go ahead.
So I looked at the sort of the how the committee is comprised of, and I saw that there's about 5 bio-related experts on it and 1 theoretical chemist. And so we talked about CRISPR, and I also agree it's a very important discovery. But I think something that precedes CRISPR, and actually something that fundamentally changed the way that folks in the biotechnology and also molecular biology do things is really enabled by the automated synthesis of oligonucleotides, and that's something that hasn't received the recognition yet, although it has enabled all of the discoveries, including the CRISPR one. And so I think that's a prize that is long overdue, and I think you know, the technology that has been developed, and I think one of the 2 folks who are, you know, sort of started a lot of this technology is Leroy Hood and Marvin Carruthers, and there have been others, and there's actually several of them unfortunately passed away recently. I think that's the Nobel Prize that sort of fits in with the theme of the selection committee. I think it's extremely important to both fundamental research, right? If you look at, for example, the field of DNA nanotechnology, right, where some predict that might actually win the Nobel Prize. I think that is fundamentally enabled by the ability to create custom-made oligonucleotides using automated synthesis. And also, obviously, this technology is used in everyday life of every molecular biologist, right, who essentially access primers and then being able to do the cloning and all other things. And so I think that was my pick.
Speaking as a person who in graduate school had to work with short nucleotide or short DNA sequences, I thank these guys for me being able to go through a catalog and just say, I want that one, and you get it in a little tube. Perfect.
Right. A lot of people, I think, thank these guys, and I think that's a very important knowledge. I think.
Yeah. Yeah. All right. Well, I'm going to go quickly to my pick. I'm also, this is the person, these were the people that I selected last year, so it's my true at heart pick for this year, but I knew that Stu was going to be selecting this as well, and I wanted to give us something else to talk about, or, you know, maybe stir the pot a little bit. You know, we talked a little bit earlier, I think Carmen said, right, some of these prizes, you kind of have to get one prize before you can get the other prize, and so I picked Alan Bard here, and again, I picked one person there, depending on what they would honor this for, you know, there could be other people included here, but, you know, Alan has done some serious fundamental work on electrochemistry. I mean, he has a textbook that is still the Bible. People say, have you read Bard? They don't even refer to it by its title. And, you know, he determined fundamental chemical reactions at electrodes. So without those, you wouldn't have batteries. And, you know, he learned how you could have these radical reactions or radical ions that form at electrodes, and then he saw when these things could come together, and he learned a lot about electron transfer. He learned about photoelectrochemistry. He invented scanning electrochemical microscopy. And has done a lot of really important analytical work in that way. And so I guess maybe this is another bit of a lifetime achievement award for me, but I thought I would stir the pot. And, you know, it's not that Alan has never been on other awards lists. He certainly has been, but I feel like, you know, he's in his 80s and people aren't talking about this as much, maybe because electrochemistry isn't as hot as at one time it may have been. So I thought maybe they would go for a fundamental prize this year, and wanted to see what any of you thought about it. Stu, do you have a thought about that?
A perfectly valid pick, and I guess if there weren't so many sort of candidates for a battery prize, you could maybe sort of have some kind of electrochemistry prize that included batteries too. I think with all of the picks, these are on a list of reasonable things that could be awarded the prize over the next 5 or 10 years. Obviously, there's a lot of people on these lists getting quite old. Again, the Nobel Committee doesn't really seem to take anything like that into consideration. It's a crying shame Jurassic never won the prize. And so, but yes, I think, again, a perfectly valid pick that no, I don't think anyone would be surprised.
All right. Well, let's move on. Last but not least, let's go to Matt. Matt, are you going to come back on? Oh, there you are. Hello, Matt.
Hello.
Matt,
I do. So if you remember, oh no, I shut it down. There we go. If you're an attendee last year, this is my same pick from last year. I feel very strongly about it, even though I don't really have a very scientific reason. So my pick is Mildred Dresselhaus and Sumio Iijima for work on carbon nanoscience, specifically carbon nanotubes. My overwhelming reason for this is because you have graphene in physics and you have fullerene, carbon fullerenes in chemistry, and I feel like if chemistry nabs carbon nanotubes, we win carbon science. But I think there are really good scientific reasons why this falls into chemistry. If you look at, so I have a very applied mind, right? And if you look at in terms of applicability of these materials, carbon nanotubes are doing better than the other two, right? When I was reporting for a story on carbon nanotubes, automakers have been really interested in these things as ways to enhance mechanical strength of materials while reducing their weight, but also improving the capacity of batteries. And they're very secretive about it, unlike a lot of other people that were telling everyone, oh, there's carbon nanotubes in this. The auto industry didn't want other people to know about it because they saw the value in it and they wanted to be first there to realize it. So they are useful, and I think one of the coolest things about carbon nanotubes, right, is you can control their electronic properties by their chirality. And one of the big problems now is how you sort out or grow them in that that chirality that you want, and that's very much in the wheelhouse of chemistry. So that's my pick, but maybe I believe the next slide is the poll, right? We want to know which one of us, if any, got it right. So if we could bring up the poll question, who do you agree with? Will it be lithium-ion batteries, polymer chemistry, the automated synthesis of oligonucleotides, Bard for his contributions to electrochemistry, or carbon nanotubes? We'll shut down the poll in 5, 4, 3, 2, 1. Overwhelmingly, it is good enough, and Whittingham and Yoshino for lithium-ion batteries. So Stu, being as how that is your pick, I feel like we should kick it over to you first. And do you want to gloat? Do you want to expand on that? I'll leave it up to you.
Yeah, what do I win?
Bragging rights for now.
I think it's, again, it's one of these prizes that I think no one will be upset about, no one will be surprised by. It seems to be an obvious pick, which is why I'm taking the easy option. But I do genuinely believe that this could be the year, which I'm sure I will go crashing down in flames next week when the prize is announced. But it wouldn't surprise me in the slightest if it was lithium-ion batteries. I think it'd be well deserved. And again, it's so fundamental. It has changed the way the world works utterly. So yes, go 50%. That's, yeah. Lithium-ion batteries for president.
All right. Well, that did bring up a point when you mentioned that about what do you win. For right now, you win an all-inclusive bragging rights package. But I do think that if one of us gets it next week, we're going to, promote that online, and whoever wins gets a pretty sweet like C&EN swag package or something. I'll think of something good. All right. So we have one or two more things that we want to discuss, and I'm going to do it real quickly, and then we'll go to the audience questions. So we're going to talk about, there was one other data visualization that C&EN did, and we released it a week or so ago. And actually Matt is the person who was behind this, the mastermind. But we also did this sort of, we pulled all the data from where the people who have already won, the laureates, where they were born, where they were when they won the prize, and where they were when they died. And we kind of mapped this out. And so you can see on this slide we're showing the counts by birth country, and you can see you know, a decent diversity of places here, although there are definitely some places in the world that are underrepresented. And then if you look at where these people were when they actually won the award, it narrows down considerably. And those same underrepresented places are still very underrepresented, and it gets even worse. So, you know, we don't have much going on in Central America, Africa, Southeast Asia, Australia. So, you know, just as I mentioned to the audience, I encourage you all to check out this interactive map that we have, and there's a whole bunch of fun facts that Matt dug out of the data. For instance, this may start a riot, but Stanford University is the primary affiliation for 7 of the Nobel laureates, so that's where they were when they got the prize, and I think that's the leading one of all the prizes that we've seen so far. But so, take a look at that, and for now, we have one last poll question for you, audience. Take it away, Matt.
So, you just saw the map, and there's some regions not very well represented by Nobel laureates, and we want to know how long you think it will be before that starts changing. We have 5 selections for you, less than 5 years, 5 to 10 years, 11 to 20, more than 20, or it's not going to happen. So make your choice, and we will shut down this poll in 5, 4, 3, 2, 1, and let's see the results. We've got, sorry, I didn't see that. The 38%, it looked clear to me, but greater than 20 years is a leading contender with 11 to 20 years. So a lot of our viewers think that is going to be longer than shorter. Carmen, I don't think I've gone to you first for a question yet, so I want to see, do you agree with that?
Yeah, I actually do agree with that. Maybe I'm kind of a pessimist, but I actually do think that scientific infrastructure takes, you know, decades to build. Here in the U.S., I'm concerned about things like funding squabbles at the state level, and outside the U.S., you know, countries that want to be the homes of future Nobel laureates have to commit the resources to keep homegrown talent. I could speak a little bit to Spain, which is one of the few countries, I think, in Western Europe that's not, you know, represented on your map with a Nobel Prize in chemistry. There, I mean, Spain has some proud legacies and Nobel laureates in medicine, but currently in Spain there have been years of repeated cuts to research, and young scientists are seeing the writing on the wall and leaving the country. And the government itself is kind of up in the air right now. There's a stalemate politically, and so when you have something like that in a, you know, highly developed country, and you've got, you know, the funding for science kind of in limbo, where do you go to kind of build that infrastructure?
Stu, in the UK, I'm going to toss it over to you, since Stu, in the UK, you don't know anything about political uncertainness and science funding.
Absolutely not. Yeah, I was actually at a talk last night from the creator of XKCD, and he opened up by saying he thought he'd come over here before both of our countries walled ourselves off from the rest of the world. Yes, well, when Matt asked me this question ahead of this webinar, so I mean my selection, I think I actually said greater than 20 years, but I don't think, so I think we're going to see more diversity. I think we'll probably see fewer from the UK, but the areas of the world where I think we need to watch sooner rather than later is maybe Korea, but China. The amount of money being spent on scientific infrastructure and research in China is massive, but also don't rule out places like Saudi Arabia and KAUST, where there's an awful lot of investment to try and get up to a very high level very quickly. You never know, so it depends who they can attract there.
Alex, do you have a similar view?
So I agree with Stu regarding that. I don't think we're going to see sort of world unified homogeneity in these Nobel Prizes, but certain places might start popping up more frequently, like Saudi Arabia, who have been really acquiring a lot of talent in the past several years. Again, China, Korea, Singapore, also central U.S., right? So if you look at the United States, right, it's very sort of bi-coastal, right? And I think over the next years, it would be realistic to expect there's going to be more homogeneity within the U.S. But it certainly will take some time.
Okay. Well, thank you, and thanks to the audience for voting. We're going to turn it over to you and your Q&A. Our panelists are here to answer your questions, and Matt is going to moderate this section.
Yeah, so thanks for everyone for contributing such great questions on Twitter and in the webinar. I'm looking at them right now, and please feel free to resubmit questions because there are a lot of good ones. I think an interesting place to start. We saw a lot of questions about, in the nominations and the predictions as to how did you pick those three or that group of people. I'm curious, does this exercise give our panelists a greater appreciation of what the Nobel panel goes through in selecting those? And would you do, if it were up to you, would you change the number of recipients? So I guess I'll start with Alex, since he's at the top of my screen.
Yes, I would definitely change the number of recipients, but because I think the fundamental issue is that these days the science is significantly more collaborative than I guess it was 100 years ago, where Nobel actually lived. And so I think there's just more players right now, and in order to make sure that everybody significant gets the credit, I think it would be reasonable to have definitely more than three. I think in many discoveries there's definitely more than three people who have major contributions to the discovery. So.
Carmen, do you have thoughts?
Well, after this, I definitely appreciate the difficulty that the Nobel Committee faces in picking, who is the right person or people to get this prize. I think it took decades for them to sort out things like palladium catalyzed cross-couplings, so there's one. But, you could increase the number, but how do you set the limit? Because unless the number is infinity, if your goal is to stop, somebody from, for example, taking out an op-ed or an ad in the New York Times to say that there's been massive injustice, I don't think that's going to stop no matter what your limit is, because I think, as Alex said, science is a massive collaborative effort now. But then on the other hand, you're going to have stories like the GFP story, and you have Doug Prasher, who ended up driving a minivan after having made key contributions to kind of the background of that. I think it's just far be it from me to make changes to the Nobel will.
And Stu, I really liked your nomination because your first one's right, pick six and let Nobel Committee sort it out. Would you, if you were on that committee, would you have that same feeling?
So I'm actually very much a traditionalist when it comes to Nobel Prizes. The Nobel Prizes are the Nobel Prizes, and I think it should be limited to three. That's what was set. And you often hear people talk about, should the subject areas change as well? Should the Nobel Prizes change to reflect not only how we do science now, but also the subjects that we do and the more cross-disciplinarity? And the answer is no. I think you should leave them exactly as they are, the way they're intended. They've got this history, this sort of tradition. And if you want prizes for different areas of science or larger collaborations, start your own prize, which is exactly what some people have done. You have the Kavli prizes, you have rich internet billionaires in California and rich Russian billionaires starting their own physics prizes, medicine prizes. So leave the Nobel Prizes alone. And I realise I nominated 6 people, and yes, so if I was on that committee, that would be a huge pain. But no one will really find out the machinations for the next 50 years of how they actually settled on the 3 in the end. So no, leave them be. I imagine it's a very difficult job. But I imagine it's also quite a fun job. So no, leave them as they are.
Lauren, I know that you had the difficult challenge of selecting 12 up-and-coming chemists for our Talented 12 feature, and even 12 is difficult. How do you feel about 3?
Oh, good God. 12 was hard enough. There's so many things that you think about, and I know that Nobel isn't necessarily bound to these things, but we started our own, as Stu said, we started our own thing, so we get to make choices. And we thought about geographic diversity, we thought about different types of chemistry, we thought about male and female, we thought about race and underrepresented minorities. We tried as hard as we could to balance those things and stressed ourselves out for months, and still I got a letter that said there are too many people from California universities, which, I mean, it's a completely valid thing to say, but you try your hardest, and it is pretty stressful, but also really fun. I mean, I got to meet Alex, who is an awesome person, and you kind of see them go on to do great things, and you feel really good about it. So I can imagine that it must be the same thing for the Nobel Committee. Well, probably even better. I'm not comparing myself to the Nobel Committee, just to be clear. So
one of the questions, and Stu actually did a great job, I could have used his answers as a segue. We don't really know how the Nobel Committee does this, but online people are curious about how much you think previous awards improve or change the stock of a Nobel nominee. One of the specific examples was Professor Yu getting the MacArthur Genius Grant. Does that change his stock and how these things are evaluated? So let's start with Alex, because I feel like it's been a while since you talked.
I'm pretty sure that it does matter because it sort of reaffirms that the other committees think that this discovery is indeed important. But if you look at the history of the Nobel Prizes, I don't think that is definitely, it's not definitely the only factor when the committee decides these, because there's been a number of examples. Well, graphene would be one where the discoverers have not received any of those sort of prizes that are considered to be the, this proper checklist for them to receive the Nobel, like the right. So I think it should be decided on a case-by-case basis. But it certainly helps with, I guess, maybe those who are a little bit older, right? Because by then they would collect those awards, and it would be just a natural thing that everything leads up to the Nobel. But maybe with younger potential candidates, I don't think these would matter that much.
And just going down the list as I see it on my screen, Carmen, how do you see the awards fitting into the previous awards fitting into the Nobel equation?
I agree with everything Alex said. I mean, look, it doesn't hurt, but once in a while you're going to get somebody like a Don Sheckman who comes out of nowhere with his quasi-crystals, and he wasn't really on any top 10 lists. And that's the way the Nobel Committee likes it, I think.
And Stu?
Yeah, they don't always line up. So I think with the DNA Repair Prize last year in chemistry, I think a similar prize had been given, the Lasker Prize maybe, and it was, or maybe the Wolf Prize, I forget which, and it was to a different subset of researchers. It wasn't exactly the same as the Nobel plumped for. So I mean, it can't do any harm. I mean, the more awards you get, the more recognition you're going to get. It's sort of a self-fulfilling prophecy. But maybe the Nobel Committee are going to do their own thing. So it's not going to play a huge part.
Great, and I'm going to get to the last question. Sorry, Lauren, just to give us some time for wrap-up. But the question that I thought was the best is, how much stock should people put in your predictions / what is your success rate? And I think sort of an interesting corollary to how often do we get it right is, how often do you think the Nobel Committee gets it right?
Define right.
That you agree with, right? I guess that's a very vague. So how often as a percentage, right, how often do you pick what Nobel picks? And how often do you agree with Nobel picks are the two questions. So Carmen, we'll start with you. We'll start in the middle of the screen.
Oh gosh, I mean, agree. It's I don't really think of it that way for myself. I think of it as this is the one day that chemistry is on the front page of the newspaper, and even if it's biology, as some people like to argue, I'm just eager to see it on there. And
very diplomatic. Oh no, I cut you off. I'm sorry. Go ahead.
No, that's all. That's all I had.
Alex, have you ever gotten it right before? Has your prediction ever been right?
Well, I'll tell you more. Based on my experience going to Vegas, I don't think anybody in the audience should really use my prediction for anything. I don't think I've ever gotten it right. But I have to say that, and I agree with Carmen, but moreover, I think that every laureate who gets the Nobel in chemistry, at least, they deserve it, and I think these are great contributions. I think these days we just have significantly more awesome science than there's ever going to be Nobel Prizes available, just given the fact that science is so vast these days. And I also get excited anytime there's a New York Times article that actually talks about something interesting rather than the normal stuff they write about once a year. That's a great thing.
And Stu, have you hit it right? And how often do you agree with the Nobel selections?
So in terms of guessing right, I mean, for someone whose job it is to try and pick what we think of really great papers, I probably shouldn't admit that I've never got it right. But yeah, I haven't. So, but no, in terms of whether I agree, I mean, who am I to say whether I agree or not? Everyone who has won the Chemistry Nobel, as has been said before, they deserve the prize. Would I pick different people on some occasions? Probably yes, but we're all human. We all have our own likes and dislikes. It's a very subjective process. It's like me suggesting molecular machines. I mean, there are probably many people out there now sort of shaking their fist at me going, oh, molecular machines, never going to happen. So, I mean, who's to say what is right, what isn't? It is what it is, and whoever wins the Nobel Prize in chemistry deserves it.
So, Lauren, I'll turn it over to you and let you. Do we have time for
Yeah,
thoughts?
for my thoughts. Well, I will just say that I did get it right once, so woohoo! I didn't get the whole thing right though. So the year that the folks won for super resolution microscopy. It's been a long day already. But I had guessed W. Murner and some other people, and I got him right, but not the other two people that were awarded. So, I think who knows what goes on in the brains of the Nobel Committee. And I think, again, that's, I guessed that because it had been predicted for a really, really long time, and I can't really take much credit for it. So, yeah, and I mean, I agree with everything that everyone else said. We've done some stories about, last year, for instance, the DNA repair thing, which Stu brought up. So there were people that won the Lasker Prize the year before, or maybe that earlier that year or the year before, and they weren't the people who won the Nobel Prize, and so everyone was asking questions about, like, who got left out, and we did an article about that, and if you think about when you do that, you don't want to make it seem as though the people who did win weren't deserving of it. It's just this whole process of looking at the history and everything, and everyone is deserving of these prizes. But all right, I'm going to ask for some final thoughts here. Let's just do a speed round to wrap things up. Is there any last thoughts that you'd like to leave the audience with, whether it be something we didn't talk about today, or a pitch for, or one last pitch for someone that we haven't talked about? Let's start with Alex.
Well, I would be happy if anyone who Carmen, Stu, you, Lauren, and Matt nominated and predicted today. I think they're all great candidates, and I think whoever wins with the nomination would be, I would be very happy to see them deserve it. So,
Carmen?
Yeah, so I said before that, this is the day that chemistry is on the front page of all the papers, and I would hope that whoever does win the prize will take advantage of that bully pulpit of all the microphones that are going to get shoved in their face and talk about the fact that chemistry is doing amazing things and that chemistry is really a science that's solving big questions. I think of people like Rick Smalley, and I think of the legacy that he left behind, and I hope that that continues.
That's awesome. Okay, Stu?
I mean, just to echo what Alex and Carmen said, it's a great day for chemistry, whatever the prize is. I just hope it's good enough this year.
All right. Well, on that, Matt, take us home.
All right. I'd like to thank our panelists and, of course, everyone out there for tuning in. I did want to ask, did you know that C&EN and ACS webinars are just two of the many benefits that ACS has to offer? So to find out more information about those benefits, please visit http://bit.ly/ACSjoin. We're also very curious to hear what you thought about today's broadcast. You'll be emailed a short survey after this webinar today, and it should only take a few minutes to complete. Also remember that the recording of today's presentation will be available sometime later this week, and that's about it. On behalf of all of us here at C&EN, thank you so much for joining us, and we shall see where our predictions lie on October 5th. Thank you.
Bye, everybody.
Bye.
Bye.